Hey all, welcome back to my channel. Okay, today in today's channel session we are going to discuss about Verilog tasks. Okay, so in the previous session we have already discussed about Verilog functions and the difference between dynamic and very static functions in Verilog. We have discussed it clearly with examples. If you didn't check that video, I'll link that in the description box. You can go there and check out. And also, if you are new to my channel, consider subscribing my channel and hit on the notification bell also, so that as soon as I upload the video you will get the notification. And also, many of you are watching the channel without subscribing it. Please don't do that. Please subscribe the channel before watching my videos, because your subscription means a lot to me, and also it gives me motivation to upload more such videos, right? So let's dive into our topic today, which is Verilog tasks. So we have seen what are Verilog functions and what are the limitations for Verilog functions. Okay, so because of that limitations in functions, we can't use functions in everywhere. Like we can't write a piece of code which contains some time consuming constructs like wait or delays or pauses. Okay, for all these things we can't do that in functions, because of which we are coming for tasks. Okay, when coming to tasks, unlike functions, we can use all these timing constructs. Like we can use delays, you can use wait, you can use pausage of clock. So all these things we can do in this task, which is why we can use it in both blocking and non-blocking assignments. Because of this limitation, like since we can't use delays and all in functions, we can't use the function in non-blocking assignment. Okay, so that is why we can use the tasks in both blocking and non-blocking assignments. Okay, this is one of the major advantage coming to tasks. And also, when it comes to Verilog functions, while we have discussed some rules in writing the functions. Okay, there we have already discussed that the function will be returning only a single value, and also it should have at least one input. Is it or not? But in task there is not, this is not the case, because we can have any number of inputs and it can generate any number of outputs. Okay, unlike function, that means function can only return one value, but there is nothing for like that in case of task. Okay, these features mean, so because of all these advantages in task, we'll be using if you are writing any flexible piece of code, when you are writing any code which includes all these things like delays. Okay, and it has to generate more number of outputs. So if you are writing a code which includes all of these things, we will be mostly opting for task instead of Verilog function. Okay, right? And also we can create global tasks which are shared by all modules in a given module. Either it is a function or it is a task when you are writing outside the module. Okay, that means, for example, when you are writing, when you are going for the code, okay, it will be between module and end module. Is it or not? Okay, but whatever you are writing within the outside of this module, it can be shared for all the modules. That means when when your code contains some 4 to 5 modules, okay, so all these modules can share the thing that you have globally written. For example, if you are globally writing some task, this task can be shared for all these modules. That is what the meaning of this particular thing. Okay, right? Now let us see what is the syntax of task. Okay, syntax of task is similar to function. Okay, just like how you write the function, you will write the task. There is no change in that, but instead of function and end function, you will be using task and end task. Okay, so task name, what are the inputs and outputs you will be presenting, you will be writing within the argument list, and end task. Okay, so just like in functions, you are having two ways. That means you can declare the function inside the parenthesis after the name itself, or you can just leave the empty braces and you can declare all the input and output ports, in outputs also within this particular task. Okay, there are two ways. We have already discussed this in function, so I don't want to discuss again this in task because both are same, right? Now let us see an example for this task. Okay, whatever it is, functions or tasks, the main important thing is, because function is having many limitations, they have rules. Okay, that's why we have discussed particularly the rules of writing a function. But when it comes to task, there is nothing like that. Okay, just you need to do the thing like you should be what you want to um, write within the task, you should be writing within this task and end task. That is the only thing that you need to remember regarding tasks. Okay, so if you see the function here, okay, within the module I am taking some OP, some variable. Okay, and then I am writing two tasks here. You can write any number of tasks you want in your module. Okay, so my first task, if you see, print. Okay, this is the name of my tasks, and I didn't mention any input and output arguments, because there is no limitation for task that it should compulsorily return some value or else like that. So it may contain number of variables, number of input and output variables, but it may not contain any variables also. That is also fine with the tasks. So I didn't mention any variables, input output variables or anything within the arguments. Okay, so I am writing this task in order to print some statements in my log file. Okay, that is what I am doing here. So print is the name of that. Within this I am writing two display functions. Okay, in one display function I will be printing from task, okay, output from task percentage b. So these are the two display functions I am writing within this task. Okay, with name print. And then I have ended the task. And if you come to my second task, now I am using a second task with name sum. Okay, so within this I am taking two inputs like a and b and one output sum. Clear? So these are my two inputs, and which are of 4-bit wide. Okay, a and b, and the output is sum. And then within the begin and end I am writing the logic of my task. Okay, nothing but the body of the task. Here within the body, what you are writing? One display function in order to display some characters like calculating sim. Okay, sum. Okay, and then I am taking hash 10 time units, nothing but delay of 10 time units. Okay, after 10 time units of delay, I am writing the logic like sum equal to a plus b. I am ending task. Okay, so this is one task, and this is the another task I have written in some part of my code. Clear? Now within another part of my code, like anywhere within the code, I am writing some initial begin, and now I am calling my task named sum. If you see this, what is this? This sum is nothing but the name of the second task. Okay, now you are calling this sum. So if you see this, here it is having two inputs. So the two inputs are 10100101. Okay, and then if you see, this is the sum. Okay, the sum is the output. Here this OP is related to sum. Did you get my point? Why is it? Because in the starting we have discussed that the task can generate any number of outputs. Okay. So because of this, you will be equating, you will be automatically passing the output that you want to be assigned. That means when you are adding these two, you want to assign it to some variable. Is it or not? So you can directly name that particular output which you want to assign in the task itself. Clear? But you can't do such thing in function. Okay, this is also one of the advantage. That means you can directly mention all the inputs and outputs within the task itself, within the place where you are calling the task. Okay, now what happens? 100101 is added and the answer is assigned to OP. Clear? So this is my first task. Now if you see the second task, print. Okay, what is this print? This print is my first task that I have written. So we are calling the print here. Now what happens? So end module completed your code. Now if you see the output, first what you have done, you have called the sum. So it will be coming here. Okay, in the sum, what is the first thing? Okay, that is calculating sum at percentage t. That means this task is called at 0 time delay. So that is why at 0 calculating sum. Clear? So then what happens? And then there is nothing in this. This is the logic. That means this, in order to display this logic, you need this particular thing need to be called or need to be displayed somewhere. There, what is that? That is print. Okay, if you see the print, if you calling the print, then this particular task is being called. Now in this particular class, what is the first display? At percentage t, printing from task. Okay, now what is the percentage t here? If you see, I have waited for 10 time units in order to calculate this particular thing. So that is why at 10 time units of after 10 time units of delay, I'll be printing this printing from task. Okay, this first display function is printed. And then what is the second display function? At percentage t, that means at percentage 10, output from task, which is percentage b, in the format of percentage b. That means I want the answer in binary format. So 1010100101, nothing but 1111. So this 1111 is printed. Got my point? That is OP. Okay, clear? So this is how you will be writing a task. Clear? If you are not clear about this, you can ping me in the comment box so that I'll be answering your doubts. Clear? Now, if you see the second example here, module task example, okay, nothing but this is just one more simple code. Here, I have written only one task named compare, which consists of two inputs A, B and output done. Okay, so within this I am writing the task function body of my task. That is, if A greater than B, I want to display this. That means I am writing some conditional statements here. If, if, else. Okay, A greater than B, A less than B, A equal to B. And then after this, I am waiting for 10 time units of delay, and I am assigning the value done equal to 1. That means I am assigning the value for done also here. End task. Now initial begin, I have taken a bit named done. Okay, here this done and this done is not same. Okay, you can use any bit here, any bit variable name. Like you can use done one also. That is also same here. Okay, either done one or anything like output. Just in the previous example, if you see, I have used the sum here, but I have used OP here. In the similar way, you can use two different name variable names, or even though you are taking the same name also, there won't be any issue. Clear? So compare. I am giving two values. What are the values? 10 comma 10. That means 10 comma 10 and done. Okay, this is done is equal to that particular done. Okay, if done. But if you see here, it will be starting now. If you are calling this compare, what happens? It will be calling this particular compare function. Okay, now after comparing, what it will do? It will be comparing these two values. 10 is greater than 10. It will be comparing if condition, else if else. Okay, and then it will be displaying, since 10 is equal to 10, it will be displaying this, and then it will be waiting for 10 time units of time delay, and then it will be assigning done equal to 1. Okay, now after this after it comes out of end task, what is the thing I want to display? If done equal to 1. That means if this is done, if done equal to if 1. Okay, what I want to display? I want to display comparison completed time. So I want to like, since I have called it one time, so my comparison is done. So I want to display my comparison is completed at what time? Now if you see, this comparison is completed at 10 time units of delay. Okay, is it or not? Because before ending the task, it has waited for 10 time units. Is it or not? So this comparison is done at time 10. Clear? Again I am calling compare function. Now again the values of A and B are 5 and 9. Okay, and now again the conditional operation is done. Again the comparison is done. Again it will wait for 10 time units, and again it will be ending the task. So now what happens? Firstly it has waited for 10 minutes, 10 time units, and it has waited for 10 time units. So the total is 20 time units. So that is why the second comparison is completed at time 10 equal to 20. Now when you are calling the third comparison, what happens? It will be waiting for another 10. Okay, because it is the time delay is 10 here, so that is 30 here. Okay, so the first comparison is completed at 10 time units, second comparison is completed at 10 time 20, third comparison is completed at 30 time units. Okay, so this is how the working is done for this particular thing. Clear? Hope you are clear about this particular task example. Okay, if you're still having any doubts, as I told you, I'll be definitely answering you. You can ping me in the comment box. Now let us come to automatic tasks. Okay, I'm not preparing particular again one more session for this because we have already discussed about automatic functions. So the same is applied to automatic tasks also. Okay, there is no difference between automatic functions and automatic tasks. So when it comes to automatic functions, you know the difference between static functions and automatic functions. Is it or not? So in static functions, the memory is allocated as soon as you declared the function. But in case of automatic function, what happens? The memory will be created whenever you call the function. The memory is created at that particular point of time. Similarly in task also, when it is start task, it is the memory locations will be allocated as soon as you declare the task. That means as soon as you have returned the task, it will be allocating the memory locations. But when it comes to automatic task, what happens? The allocation of the memory is done when you are calling that particular task. Clear? Yes. So that is the difference between static task and automatic task. And just like in static functions and automatic functions, by default, when you are just naming the task, if you see here in this where you didn't give any name like automatic, since by you didn't give any automatic keyword, so by default it is static in nature. Similarly, where if you don't give any keyword like automatic, that is by default static in nature. But if you are giving an automatic keyword, then that particular task is automatic in nature. Okay, and the main difference between static and automatic functions or either tasks, both, okay, is that here the memory once you created, that means once the memory is created after calling the task or function, is freed as soon as you end the task. Is it or not? Okay. If you don't get this particular thing, I'll link that dynamic memory in functions in the description box. You can also go check it out there, because since I have already explained clearly about the dynamic functions, I don't want to waste your time on automatic tasks. Okay. So first, if you have not seen that particular automatic functions, since I link that in the description box, you first go there and check it out and then come here. Okay. So those who have already listened about the dynamic functions, okay, you will be clear about the automatic tasks, right? So let us see an example of how this automatic, what is the difference between automatic tasks and static task. Okay, if you see here, this is my task. If you see the task here, I have written task increment, and within this increment I have taken only one input INCR, which is of integer type. Okay, and then integer I equal to 1. Okay, so I am taking another variable I, which is again of integer data type, and I am giving the value 1 to that particular I. Okay, and then I am writing the body of my function, which is I equal to I plus INCR, and then display result of increment equal to percentage di. So after writing this logic, I want to display the value of I and end task. Okay, so this is my particular program. Now if you see here, initial begin, I am calling my increment. What is this increment? That is the task. So what is it doing here? Increment 1. That means here the INCR will be 1, and obviously I equal to 1. Now what will be the I value here? 1 plus INCR is 1. So 1 plus 1, which is the I value will be equal to 2. So what is the value at the first time? I equal to 2. Fine, right? And then again I am calling increment of 2. Now what happens? This INCR is 2 now. Okay, I is automatically 1. Sorry, I is 2 here, because it will be holding the previous values. Is it or not? So before the value of I is 2, so the value of I will be 2. Is it or not? So that is 2 plus, what is the value of INCR? 2. 2 plus 2, which is 4. Okay, so the I value is 4 now. Clear? Okay, and then again I'm calling the task. Now what happens? Okay, if you see in that first time while I am calling my I increment 1, the INCR value is 1. Okay, the I value is 1. Okay, and the final output of I is 2. Clear? When the second time I am calling, my INCR value is 2. Okay, my I value is 2. So after logic is done, my I value is 4. Clear? When in the third time, my INCR value is 3 and my I value is the before value, which is 4. Clear? Now what will be the value of I? Nothing but 4 plus 3, which is 7. Okay, so my I value will be 2, 4, 7. Okay, let us see the output. So see, result of INCR is 2, 4, 7. Clear? Yes. Now the same program, like I didn't change any inch of this code, but what is the only thing that I have done is automatic. Okay, if you see the output now, what is the output? 2, 3, 4. What is the before output? 2, 4, 7. But as soon as you have changed it from static to automatic, the values are changed from 2, 3, 4. Why? Okay, now let us see this. Again, the same process we will be doing. At the first step, the INCR is 1, I equal to 1. So, I equal to 1 plus 1, which is 2. Fine. Okay. Now, if you see here 2. Yes, got it. Now, if you see the second time you are calling that INCR is 2. But I is not 2. I is 1 here because as I told you when it is an automatic function, as soon as you have ended the function, the memory will be freed. That means the I value is erased and it is again the default value of either 0 if I is integer data type, so its default value it will be going to its default value. Okay, now again you are assigning the value of I as 1, so again the value of I is 1. Now what happens? I equal to 2 plus 1, that is why it is 3. Okay, now if again when you are incrementing for third time, that means again you are calling the task for third time, INCR will be 3, but I won't be 3, I will be again 1 because as soon as it is ended, again this 3 is also freed up. So again 3 plus 1, which is 4. So that is why it is 4. Okay, hope you got the difference between static and automatic tasks. Clear? Yes, this is the difference. Like this is about Verilog tasks. Okay, now let us discuss about what is the difference between task and function. Okay, I have prepared this table for you since many of you are asking me like tell us the difference between system functions and tasks so that you can take this snap and when you are going for any internship return test or else when you are going for any interviews, you can just check this out and it will be good to use for you. Okay, so when it comes to task can have 0 or more than one arguments. Okay, that means it can have either 0 arguments or it can have like two inputs, two outputs, any number of arguments it can contain when it is a task. But the function, it shouldn't be empty, it should have at least one argument, that you should remember. That's why, so basically whenever you see any codes, okay, like if you see here, just a second, see here when you are writing a place where in if you are writing some, if you have seen any big codes in system verilog and all, okay, they will be particularly like writing all the display functions there in one particular task, but they will mostly use task but not function because basically when you are writing like such type of things like where all the display functions will be packed at one point, okay, for that you don't need arguments, but for function you at least need one argument. That is why you will opt for task when you are writing like these tasks like print, where all the display functions are packed at one point. Okay, so on such cases you will be using the task. Okay, so this is one major disadvantage we can say in function, that is it should have at least one argument, but without an argument you can write a task. Okay, and the second thing is task can have delay statements, obviously, but function cannot have delay statements. That means it should return value at that time step of time. As soon as it has completed, it will return the value. It doesn't opt for any delays in function. Okay, task does not have return type. This is also one advantage in task, but a function should have return type. Okay, even though if you are not, if it is not having any return type, also we'll using a void return type. Okay, right? A task can return more than one values, but a function can only return one value at a time. This is also one big difference. Okay, right? And a task can call another function or a task from. This is the most frequently asked tricky question. Like say many either a task can call a function or a function can call task. Okay, I have already discussed that in the previous session itself, like when you are discussing about functions. Okay, but here also a task can call another function because task is more flexible, okay, than function, because functions is having its limitations. Since function is having its limitations, it can't easily call another task. A function can call function, a function can't call task. A task can call task can call function. Okay, if you're still confused, just remember one small thing. Since task is more flexible than function, it can do anything. That means it can call either a function, it can call either a task in that way. But since function is having limitations, it can call only function. It can't call the task. Just remember it like this. Okay? Okay, right, clear? So this is all about the difference between functions and tasks. Okay, in the next session we will be discussing about compiler directives in Verilog, which is also very important. And I have like so many of you have asked me like what are compiler directives, to explain about compiler directives and tags, explain about mainly time scale compiler directives and all. So I'll be explaining that in the next session. Please don't miss it out, and also consider subscribing my channel. Thank you.